Properties of inverse trigonometric ratios. Sine inverse of sine theta is equal to theta. Cos inverse of cos theta is equal to theta. Same way, tan inverse of tan theta is equal to theta. This holds good for their reciprocals also. So, cosecant inverse of cosecant theta is equal to theta, secant inverse of secant theta is theta, and cot inverse of cot theta is theta. Now, let us do two example problems related to this. Evaluate sine inverse of sine pi by 3. Sine inverse of sine theta is equal to theta, so therefore this is now going to be pi by 3. Evaluate tan inverse of tan 3 pi by 4. We would all immediately say tan inverse of tan 3 pi by 4 is equal to 3 pi by 4, but this is not equal to 3 pi by 4 because tan does not lie between minus pi by 2 and pi by 2. So we'll have to take tan inverse of tan of pi minus pi by 4, which is equal to tan inverse of minus tan, because tan in the second quadrant is negative, so minus tan pi by 4, or which is equal to tan inverse of tan minus pi by 4, which is nothing but minus pi by 4. Now let us look into the other properties. Same way, we can also solve another problem like this, similar to this. Evaluate tan inverse of root of 1 minus cos x by 1 plus cos x, which is equal to, between the intervals minus pi lesser than x lesser than pi. We all know that 1 minus cos x is equal to 2 sine squared x by 2, and 1 plus cos x is equal to 2 cos squared x by 2. Now, putting that in the place of 1 minus cos x and 1 plus cos x, you get root over 2 sine squared x by 2 divided by 2 cos squared x by 2. 2 and 2 gets cancelled, so that gives you tan inverse of tan x by 2, which is equal to x by 2. Now let us, children, sine inverse of x plus tan inverse of, cot inverse of tan inverse of x plus cot inverse of x is equal to pi by 2. Cosecant inverse of x plus secant inverse of x is equal to pi by 2. I'll repeat. Sine inverse of x plus cos inverse of x is equal to pi by 2. Tan inverse of x plus cot inverse of x is equal to pi by 2. And cosecant inverse of x plus secant inverse of x is equal to pi by 2. Now let us look into the other properties. Sine inverse of x plus sine inverse of y is equal to sine inverse of x into root of 1 minus y squared plus y into root of 1 minus x squared. Same way, sine inverse of x minus sine inverse of y is equal to sine inverse of x root of 1 minus y squared minus y root of 1 minus x squared. The second one, cos inverse of x plus cos inverse of y is equal to cos inverse of xy minus root of 1 minus x squared into root of 1 minus y squared. Same way, cos inverse of x minus cos inverse of y is equal to cos inverse of xy plus root of 1 minus x squared into root of 1 minus y squared. Third one, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy. Same way, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Now let us evaluate problems related to this. Prove that sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to sine inverse of 77 over 85, which is also equal to tan inverse of 77 by 36. Now we can use the formula sine inverse of x plus sine inverse of y. So that would give you sine inverse of 8 by 17 root of 1 minus 3 by 5 the whole square, that is 9 by 25, plus 3 by 5 into root of 1 minus 8 squared by, that is 64 by 17 squared. This is nothing but sine inverse of 8 by 17 into 4 by 5 plus 3 by 5 into 15 by 17, which is nothing but sine inverse of 77 by 85. So now if you draw the triangle, you can see that sine is nothing but opposite by hypotenuse. So that would give you, this is going to be opposite side is 77 and hypotenuse 35. By using Pythagoras theorem, you can find out the third side, that is which is nothing but 36. So we can see that this is also equal to tan inverse of 77 by 36. Now let us look into another problem, something related to this. Prove that sine inverse of 12 by 13 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16 is equal to 5. Now, let us look into this problem. Now we can take sine inverse of 12 by 30 plus cos inverse of 4 by 5 plus tan inverse of 63 by 16. So I will convert this cos inverse of 4 by 5 in terms of tan and sine inverse of 12 by 13 also in terms of tan. So now we know 5, 12 and 13 are the Pythagorean triplet. 3, 4 and 5 are also Pythagorean triplet. So obviously from this I can write the sine inverse of 12 by 13 in terms of tan as tan inverse of 12 by 5 plus cos inverse of, tan inverse of 12 tan inverse of 3 by 4 plus tan inverse of 63 by 60. Now I have converted everything in terms of tan now. So tan inverse of, I can write this as, so he says this is equal to pi. So I can take this as the first two. I can use the formula tan inverse of x plus y by 1 plus xy. So that will give you tan inverse of 12 by 5 plus 3 by 4 divided by 1 minus 12 by 5 into 3 by 4, which is nothing but tan inverse of 48 plus 15 by 20 divided by 20 minus 36. So that gives you 20 minus 12, it's a 36 by 20. So that gives you, which is equal to tan inverse of 48 plus 15 is 30, 63 by minus 60. Tan inverse of minus 63 by 16 is nothing but pi minus tan inverse of 63 by 16. So from this we have proved that. Already we've got that. You can look into the problem. It is nothing but tan inverse of this is equal to pi. So we need to prove that it is equal to pi. So therefore tan inverse of 63 by 16 is equal to pi. So hence it is proved that this is equal to pi. LHS is equal